Welcome back. Besides plate tectonics, what else goes into shaping the coast? What's happening at this interaction between land and water? Well, waves. Waves are another big one. Waves are generated by offshore winds. Sometimes this wind can come from thousands of miles away and essentially create waves that travel that far before they hit any shores. So thinking back to last unit. So wind is generated by the energy from the sun, causing the uneven heating of the earth. And so ultimately the energy from the sun is driving the wind. The wind is, as it blows over a water, it starts to blow that top surface with it. And over time, if that wind is pushing for long enough or far enough, it can build up waves. So in essence, the sun is coming, or the energy is coming from the sun to the wind is transferring that energy to the waves. And when those waves finally do hit the coast, they're transferring that energy to the coast. So that's where this destructive energy comes from, ultimately from the sun. Darn you! So wave energy. If you're trying to figure out how much energy a wave has, it's proportionally approximate to the square of the wave height. I know, it's got mathy there. Let me explain. So think of a 1 foot wave, a 2 foot wave, and a 3 foot wave. All right? So if a 1 foot wave has, say, one amount of energy, well, a 2 foot wave has the square of that. So 2 foot, so 2 times 2 is 4. So a 2 foot wave has 4 times the energy as a 1 foot wave. A 3 foot wave, square that, 3 times 3 is 9. So a 3 foot wave has 9 times the energy. 4 foot wave would have 16 times the energy. A 5 foot wave would have 25 times the energy of a 1 foot wave. So the energy is proportional to the square of the wave height. So it gets exponentially bigger. The energy becomes exponential the bigger the wave gets. So even though a 1 foot wave and a 2 foot wave doesn't seem that much difference, there's 4 times more energy. So you can see the bigger the wave, the more energy that's hitting the coast, the more it can really shape the coast and create different types of landforms. Now, when we're talking about landforms, we actually see different types of landforms at passive margins. Passive margins, we have these barrier islands, which I spoke about. Very common also beaches, these nice big sandy beaches. Versus active margins, where you get many different kind of landforms from passive margins. And typically they're very rocky, rugged terrain types of landforms. So that's a big thing with the different types of margins. Waves create different types of landforms. Also, waves do a good job of transporting sand and sediment, building up sediment in sand structures in one place, taking it away, weathering and eroding it from other places. So now some beaches are devoid of sand, while others have a bunch of it. So there's a bunch going on, but all that movement is due to waves. Excuse me. And just like a tsunami, what we talked about, waves, tsunami is just a bigger wave essentially. So when the waves are coming, as the ocean floor becomes shallower and shallower, the wave height increases, that water slows down, kind of builds up, and so you get the bigger waves closer to the surface. So that's why surfing is done kind of close to the beach. If you went too far out, the waves are going to be too small. They need to build up. That water needs to slow down, build up, before it kind of crashes over in the surf zone. So that's why surfers surf closer to the coast. You don't surf way out in the middle of the ocean. The waves aren't necessarily big enough. So when the waves do hit, for instance, active margins, those at or near plate boundaries, you get a lot of these different types of landforms. Things called wave-cut platforms, bays, sea caves, bridges, headlands, sea stacks. You do get some beaches, usually protected in bays, but it's usually very rocky, rugged terrain. So here's an example of some rocky, rugged terrain along the Pacific Ocean. So it's going to be the west coast. You see the cliffs, you see the bay. Here's some headlands. Here's some stacks. Here's a little stream kind of coming out from land to create a little bay area where you do have a little beach here, but not much. So this is, again, more typical of your active margin at or near a plate boundary. Here you see what's called a natural bridge, which is part of this headland in this bay. There's a beach, and here's some sea cliffs. Here's a great example of a sea stack, kind of just like a disconnected big lump of rock right off the coast. And those are typical of more active margins. Where you see this rocky, rugged terrain. Passive margins, you usually get more landforms made out of sand and sediment. So when sand is transported around, it can create different landforms, but sand does move around in a couple different ways. First is something called beach drift. All right, so this is the movement of sand along the shoreline due to the in and out motion of the waves, and that's known as beach drift. So I'll show you, you know what, I'll save the description here in a second because there's a picture to show. But then you also have something called longshore drift. This is where you have sand and sediment kind of moving just kind of off the beach area. Let me just show you what that is too. How about that? All right, sorry, it's just much easier this way. I could tell you all the words, but let me just show you. So you get waves coming in, especially if you get waves coming in at an angle. You see how these kind of waves are kind of like at an angle as they hit the beach? So when these waves hit the beach, it pushes sand up. As the waves kind of roll back, it pulls the sand down. Another wave comes in, pushes the sand up. As the waves kind of trickle back down, it brings the sand with it, push it back up, back down, back up, back down. And you can see that the sand kind of gets just pushed off, in this case, off to the right. That's called beach drift. And that's driven by the pushing of sand and sediment right at the beach. Well, just off the beach, just right off the coast, is something called longshore drift due to the longshore current. Some sediment can get kind of just lighter sediment can just get trapped in this area. So instead of going up and down, up and down, up and down, it just kind of stays out in this area. And due to longshore current, which is the overall kind of motion in this case of the waves kind of pushing everything to the right, up and to the right there, you get something called longshore drift, where you just get sediment pushed just off the beach. So if you've ever gone to the ocean, it's not automatically clear water. You'll see that it's pretty murky, kind of muddy for a little while out. And that's kind of the extent to where the longshore current is kind of pushing some of that material. It's a little too light to kind of get pushed up and onto the beach. It kind of stays out there, but just in this case, moves to the right because the waves seem to be kind of pushing it off to the right. Now, what I will say about this is overall movement. Waves can come in different directions. Waves are caused by wind. Wind blows in different directions. But, on average, in a certain area, wind blows a certain direction, causing beach drift, causing longshore drift, typically in a certain direction. However, if you're looking at a picture or a satellite image at any particular day, the waves can be going any which way. So just any particular one instant looking at the waves is not going to help you determine what direction the beach drift or longshore drift is. You have to look at the sedimentary structures, how the sediment is building up in one area, but maybe not building up in the other area. That gives you the overall trend in which longshore drift or beach drift occurs in an area. So again, if you're looking at a satellite image and the waves are going in one direction, that's just at that instant in time. That could be a fluke weather pattern that wind is coming in a certain direction. Just ignore that. Ignore the wave direction. You're looking at the overall direction of where the sediment is building up. And we'll talk more about that a little bit later when we talk about some of these sediment deposited landforms that we find along the coast. But in any case, waves. That's the energy. That's bringing the energy to the coast, to the rocky structure, to help move material and help change material and help create different landforms. So what we're going to do, we're going to pause there. When we come back, we'll also talk about how sea level change is affecting the coast. It's not just waves, it's also the rising of seawater that's affecting the coast. More on that in just a second.